Hello, viewers. In today's session, we are going to discuss another important problem from increasing and decreasing functions. And here we have to solve this problem where we have to find the intervals in which the function f of x, which is equal to x plus 1 raised to 5 times x minus 3 raised to 3, is increasing and decreasing. So we have to find out the intervals where this function increases and decreases. So now to get the intervals, the first step is to differentiate this function with respect to x. So first we'll find out the derivative of f of x. So f prime of x is given by dy dx of x plus 1 raised to 5, and here we have x minus 3 raised to 3. Now here we have the product of two functions. So let us take this function as u and this function as v, and here we can apply the product rule. So we have first function, then we have the derivative of second function, then we have second function and the derivative of first function. So here we have x plus 1 raised to 5, and then we have dy dx of x minus 3 cube, and then we have x minus 3 cube and the derivative of x plus 1 raised to 5. So now we can write x plus 1 raised to 5, and here we can make use of the power rule for differentiation. That is, the derivative of x raised to n is nx n minus 1. So here first we'll apply this rule. So here the value of n is 3. So we have 3 times x minus 3 square, that is 3 minus 1 is 2, and then by chain rule we can differentiate x minus 3. So the derivative of x minus 3 is simply 1 minus 0. The derivative of 3 is 0. So here we have 1 minus 0. And then here we have x minus 3 cube, and here again we'll make use of the same formula. So here we have 5 times x plus 1 raised to 4, and the derivative of x plus 1 is 1 plus 0. So now we can simplify it. So we have 3 times x minus 3 square, x plus 1 raised to 5, and then here we have 5 times x minus 3 cube, and here we have x plus 1 raised to 4. So now let us take here some expressions common from both these terms. So here we have x minus 3 square, here we have x minus 3 cube. So we can take x minus 3 square common, and here we have x plus 1 raised to 5, here we have x plus 1 raised to 4. So we can take x plus 1 raised to 4 as common, and then inside the brackets we have here 3, and here we have the exponent 5, here we have 4. So here we have simply x plus 1, and here we have 5, and here x minus 3 raised to 3, here we have 2. So there is one factor left, so we have x minus 3, and here x plus 1 raised to 4, right? So now we can write x minus 3 square, x plus 1 raised to 4, and here we have 3x plus 3, and then we have 5x minus 15. So we can now write x minus 3 square, x plus 1 raised to 4, and here 5 plus 3 is 8x, 3 minus 15 is minus 12, right? So now we can take 4 common from both these terms. So we can now write 4 here, x minus 3 square x plus 1 raised to 4, and here we have 2x and here we have minus 3, right? So now the derivative of this function is given by this expression. So now the critical points of this function f of x are given by equating the derivative to 0. So here f prime of x is 0. So we have 4 times x minus 3 square. Then we have x plus 1 raised to 4, and 2x minus 3 is equal to 0. So from here we can easily see that when f prime of x is 0, then here this factor is equal to 0, this factor is equal to 0, and this factor is equal to 0. So from here we have x minus 3 is equal to 0, that is x minus 3 square is equal to 0. So we have x is equal to 3, and from here x plus 1 raised to 4 is equal to 0, that is x plus 1 is equal to 0, so x is equal to minus 1, and from here 2x minus 3 is equal to 0, that is x is equal to 3 over 2. So here the critical points of this function f of x are given by 3, minus 1, and 3 over 2, right? So now we have to find out the intervals where this function is increasing and decreasing. Now for increasing function, we have this condition, that is the derivative f prime of x must be greater than 0 for all x belonging to the domain of this function, right? And the domain of this function is clearly the set of real numbers, right? So for increasing function we have f prime of x is greater than 0, and for decreasing function we have f prime of x is less than 0 for all x belonging to the domain of f of x, right? So here the for increasing function f prime of x must be positive, right? And for decreasing function f prime of x must be negative. So now for increasing function f prime of x is greater than 0. Now if we look at this expression, that is the expression for the derivative, we can see that here the exponent, that is 2 and 4, are even, right? So here we have the even exponents. So this term, that is 4 times x minus 3 square times x plus 1 raised to 4 is always going to be greater than 0 for all x belonging to the domain, that is 4 times x minus 3 square x plus 1 raised to 4 must be greater than 0, because here we have 2 and here we have 4. So here this term and this term are positive for all x, because here the exponents are even, right? So the sign of f prime of x, it depends only on this factor, that is 2x minus 3, right? So now f prime of x is greater than 0 only when the 2x minus 3 is greater than 0, right? So from this inequality we have 2x greater than 3, that is x is greater than 3 over 2, dividing both sides by 2, right? So what we have discussed here, this factor 4 times x minus 3 square x plus 1 raised to 4 is always positive, right? Because 2 and 4 are even exponents, right? Okay, and here 2x minus 3 must be greater than 0 in order to have f prime of x greater than 0. So f prime of x is greater than 0 only when 2x minus 3 is greater than 0, that is 2x is greater than 3, x is greater than 3 over 2. So this function is increasing function when x belongs to the interval 3 over 2 to positive infinity, right? And this function is decreasing when f prime of x is less than 0. So now this factor is always going to be greater than 0. So f prime of x is less than 0 only when 2x minus 3, that is this factor, is less than 0. That is 2x is less than 3, x is less than 3 over 2. So this function is a decreasing function when x belongs to minus infinity to 3 over 2. So viewers, here the function f of x is increasing for all x greater than 3 by 2, that is when x belongs to this interval 3 by 2 to positive infinity, and this function is decreasing when x is less than 3 by 2, that is x belonging to the interval minus infinity to 3 over 2. So here we have the real number line, this is minus infinity, and here we have positive infinity, and here we have the point, say 3 over 2. So from minus infinity to 3 by 2, the function is decreasing, and from 3 by 2 to infinity, the function is increasing. And remember, here we have the factor 4x minus 3 square x plus 1 raised to 4. So this factor is always going to be positive. So the sign of f prime of x, it depends only on this factor, that is 2x minus 3. So when 2x minus 3 is greater than 0, the function is increasing, and when 2x minus 3 is less than 0, the function is decreasing.